equivalent expressions is the idea here in this section, along with equivalent symbolic rules. I'm going to give you the definition here in a minute, but let's look at this question here. Are the expressions equivalent, meaning these two, are these equivalent? Transform these into symbolic rules and then answer the question. So the definition of equivalent expressions is this, is that two expressions are equivalent if identical inputs identical input values produce the same output values. So if we look at these two guys, we'll think of this variable here and here as the input variable, and the question is, if I plug in the same or replace this with the same value, will this resulting expression have the same values? Now, you may be thinking, well, there's no output variable here. And so the idea here is to assign an output variable to this expression, or the result of this expression, when you replace something in here for that x. And we do this a lot in math. And so, again, there is no other variable here other than this x, but what we can do is assign this entire expression to another variable. We'll call it y. So that when we replace x with a value, then the resulting value of this, we'll call it a y value. Same thing here. When we replace this with an x value, we'll call the result of that a y value. So now we got two variables. We have an input and an output here, an input and an output. Now, we're not sure if these are the same, so we often use subscripts to denote difference in output variables. So I'm going to call this y sub 1 and y sub 2. We're not sure if these two are the same, so that's why we denote these differently. But these guys, these x values, are the same and represent the same thing. These don't. So here's a one way to look at this visually, is to make a table of values. I'm going to do that right here. X, y1, y2. So by definition, again, it's when identical input values are placed into here, are these guys the same? So let's just try one. Let's just try a 2, and I'll show you what I mean here. So we're going to replace 2 in there and 2 in there and see if the results are the same. So I'm going to use my calculator here. So 1/2 parentheses 2 minus 6 is what that is. That produces a -2. So this -2 is corresponding to that input value. What about in this now, what we're calling our y2 formula? I'm going to plug in a 2 there, so that looks like this: 1 divided by 2 times a 2, and then we're going to subtract off 12. So -11. So right off the bat here, are these two expressions, what we've now translated them into symbolic rules, are they equivalent? And the answer you should be thinking is no, because that input, the identical input value into these has produced differing output values. So maybe just to overkill, let's try a 5 in here and take a look at that. So I'm going to go back and hit second enter twice. I hit second enter, and it allows me to replace what I originally put in with the first formula here, the 5, so that gives me -0.5. And then I'm going to do second enter again twice for my second formula here, replace that with a 5, and that gives me -9.5. So again, these two input values do not produce the same output values, so these guys are not equivalent. Now I'm going to show you how to do this graphically on your graphing calculator, produce this same table in another, in the next video here, but let me just do one more. I'm going to do a 0. We can probably do this in our head. Let's do 0 here. So 0 minus 6 is -6, so that will produce a -3, half of -6. 0 in there, 0 times that gives me 0, and that gives me negative 12. Okay, so let me show you this on a calculator, how you can make the same table on a calculator.